Hello and welcome to this week's episode of the Structural Engineering Podcast. My name's Zach.
And I'm Max.
And this week we're sitting down with Luis. Luis is a civil engineer practicing bridge engineering, actually here in Colorado. So he and I are somewhat neighbors. Luis runs a really awesome podcast called Engineering Our Future. The premise of the podcast is really for Luis to share his experiences and to spread the knowledge of civil engineering.
That's right. I'll read off a couple of his most recent episodes here. We've got the simple goal setting method we need to apply, how to balance work and volunteering, and writing a resume that will stand out. Luis has done some pretty cool work in just the 3 or 4 years he's been practicing. And he originally did his master's in North Dakota, maybe South Dakota, for bridge engineering and monitoring of bridges using drones.
So let's get into this week's episode. Luis, Thank you so much for joining us this week on the Structural Engineering Podcast. We're excited to get to know you and understand more of your background. To start us off, do you want to kind of introduce yourself a little bit and tell us a bit about yourself?
Yeah, so my name is Luis. I'm originally from Colombia, and I came to the U.S. back in 2012 to go to school at South Dakota State University, where I played Division I tennis for a couple of years before I decided I was not going to be a tennis player. So I just focused on my engineering career, my classes, and just being more involved in organizations. And yeah, I got my master's also from South Dakota State University, and now I'm working in Boulder. So that's been quite the change from South Dakota, but it's been a lot of fun.
Will you tell us a little about your podcast?
Yeah, so I've been doing podcasting for about 2 months now, I think.
Nice.
It's been a new experience. It's been great. I think it's helped me polish my communication skills just from talking. It's really hard when you have to talk by yourself just with the microphone. But I'm trying to just share my experience as a young engineer, just sharing my career and kind of trying to help other engineers kind of do the same. I'm really involved with ASE, SEI, and EWB. I've worked in projects in South and Central America, I think for 6 years now. And I think that's been a great experience that a lot of people don't even realize it exists. And just trying to share my experience through my career.
Awesome. I actually want to ask a little bit about Engineers Without Borders right off the bat, because it was something I didn't get to do in college. I did college kind of a little later than most people, so it was more of like I'm just trying to get out of here quickly. How do you participate in EWB as a working professional?
So right now, there's definitely a lot of professional chapters all over the U.S. There's one in Boulder. There's one in Denver. There's many big cities have even more than one chapter, but it's really similar to what the student chapters look like. I mean, you have kind of monthly meetings. Obviously, you have people that are more experienced. They have a lot of professional licenses and such. So it's easier in that regard. But it's basically the same. You have projects. Right now, we have, I think, 3 projects in Guatemala with the professional chapter in Boulder, where we're helping a few communities in a region in Guatemala kind of get access to clean water. A lot of time is distribution. A lot of time is just the water quality is not adequate. There's definitely projects in like structures. There's projects in sanitation. There's projects in all different fields of engineering. But the most common by far is water management and water resources in developing countries.
Cool. When you travel, is it students and professionals kind of going down together, or are these totally separate groups in this case?
It's totally separate groups. I actually mentored the chapter at CU Boulder, and we traveled last August to Puerto Rico. So I was like their mentor. They also have to have like a traveling mentor with them when they're traveling. For the professional chapter is more so like a project lead, because everyone is basically a professional engineer all over the time. So they don't really need a mentor, but it's really similar. And again, you get to meet all the communities, and there are projects in Asia and Africa and all of these countries that it's really different than what we do here in the US for sure.
Man, that's cool. It's something I actually always wanted to do, and I have just totally forgotten about it. I had no idea there was a like professional level of it.
So Luis, tell us a little bit about what you did with your master's. We talked offline about this, and it sounds like a pretty cool thing.
Yeah, so I did inspection of bridges using drones, and keep in mind, this was back in 2016 when I started my master's. So there were little like nothing or very little related to inspection of bridges or even structures using drones. This was a really new technology. Unfortunately, that same year, they came out with a new rule. The FAA came out with a new rule where you could fly drones just with a little permit. Before, you had to apply to this huge like exemption where you could use the drones. But right now, it's just a little permit that you get. And what I did, I'll divide it in basically two parts. The first part of the research was kind of studying the feasibility of the drone as an inspection tool, going flying near a bridge. We did a bridge in South Dakota. It's called the Keystone Y. It's a really nice like Blue Lamb arch bridge. So we did all of that. And then based on the results we got from there with the inspection and everything, we developed like a protocol of how to inspect bridges using drones. And there's a few research papers. And obviously my thesis is online. You can read more about that. And then the second part was actually integrating the data from the drone inspection with like finite element analysis models and seeing how the damage that you could see with the drone, you can quantify somehow using like the AASHTO standards and such, apply that damage to the finite element model and see how it affects the structure in terms of like distribution factors, load rating and such. That was kind of the later part of the project of the research. I didn't get to like completely finish that part of the research, but I was involved kind of in the beginning of that. So that was really interesting.
Was there any special equipment on these drones, or is this all visual observations just from a much better perspective than hanging a basket over the side of a bridge?
Well, there's a lot of people that use a lot of like later and other technologies and such, but we didn't have enough budget to get that fancy. So we just did visual inspection. I actually found a program to create like 3D models of the bridge. So we did like small sections, and then I found and kind of wrote my own like MATLAB code to determine like the sharpness and the entropy of the pictures. That way we can like narrow down. You take hundreds and hundreds of pictures. That way we can narrow down like the best pictures in that like image set. So that was something I kind of did a little bit on the side while I was doing the research.
Cool. Was the your specific project on this wood bridge, or was it more general? You know, it was like I can't remember how bridges are broken down into like there are 3 sections, but you know, was it only concrete that you were evaluating, only wood, or was it really very general?
So this bridge is considered a timber bridge. Okay. We did do like some inspection of the concrete deck and some of the pier cabs when we could see them, but yeah, it was mainly just like this one bridge. We did do like some other like small pedestrian bridges around the university, but that was more to like for us to see what the drone could do and kind of see where we could get, how close we could get to the bridge using the drone and such.
So this might be maybe a very easy answer, but what's the benefit of using a drone?
So I mean that depends what kind of bridge you're inspecting and kind of the size. I mean, if you think about a bridge as big as the Golden Gate, for example, it's really hard to get to the underside of the bridge. So it's a lot easier to maybe just go in a barge under the bridge and just fly the drone and get a lot closer than you will otherwise. There's a lot of benefits just kind of doing some inspections. There's a lot of benefits doing like construction, like management while they're building the bridge. Obviously, it's a lot cheaper. I mean, one of those buckets probably costs like $1,000 a day or something insane. So with these, you just buy it. A lot of drones right nowadays are between 1,000 and 2,000. They have super good quality. So there's a cost benefit there. I wouldn't say you can do a whole inspection just using the drone because you can really get up close and like touch the bridge and do some manual inspection. But there's a lot of benefits in maybe combining the two and kind of balancing in that situation.
Yeah, we interviewed a company that does structural monitoring, and they mostly do it on bridges. And it was interesting to learn that like inspecting a bridge is very, subjective. It's like all dependent on the inspector and their opinion. And it's just a grading scale that almost doesn't mean much. So did you have to correlate any of that information or those scales to what you were doing with the drones?
Yeah, so we got inspection reports from the South Dakota DOT, and again, we kind of remain blind to those reports at the beginning, trying to build kind of our own report and say, okay, there's some spalling in these areas and there's some cracking in this area and such. But yeah, in terms of like quantifying, there is not really like okay, it's level 1 damage, it's level 2 damage. It's not really like it's 50% capacity or such. It's just really, really subjective, and yeah, it's up to like the inspector to kind of quantify that. There is some scales like in the AASHTO manual, but again, they just give you some like general guidelines to follow, but there's nothing else, nothing more than that.
Wow, that's really cool. I want to fly drones.
It's a lot of fun.
Are you like actively flying the drone, or can you get it to the point like while the inspection is going on, the drone can just capture footage based on the dimensions, like it can sense where the bridge objects are and make its own passes, or do you have to actively drive it around?
So we actually like flew around. When I was doing my like literature review, there were some people that are trying to like create codes to make the drone fly by itself and inspect like certain regions of the bridge, which will be like really useful when you're trying to like monitor, like let's say a band that is, I don't know, cracking too much and you want to inspect it like multiple days. That would be really easy to do. I know there are programs that let you kind of schedule the drone flight, and then you can just automate it a little bit better, but we didn't really mess too much with that when we're doing our research.
Cool. And it seems like there's a lot of potential there. Do you what's your feeling on how long it will take until this is commonplace, or do you think it will be?
I think in a lot of the bigger cities, it already is. I know a lot of people are doing a lot of inspection, especially in buildings and like high-rise buildings during construction, and even just for like inspection in general. I think a lot of people are using it already. It may not be as mainstream just because there is not like a certain rules to inspect the bridges or buildings using drones, but yeah, I'm sure that will come eventually, and that's when it will become more widely available.
Absolutely. I think in the private sector, it's gonna, like you're saying, it's here. It exists in the private sector. Getting it over to be on the federal side, where it's an accepted way to do inspections, might have some, I don't know, difficulties getting there, but
there's certain DOTs are already implementing it. I think like the Minnesota DOT is really actively doing research and trying to implement it. We did a survey. I can't remember which other DOTs are kind of looking closer at that, but I remember the Minnesota DOT is actively pursuing kind of drones as bridge inspection tools.
Yeah, I went out. It was like right when I started structural engineering. Went out on a massive job site, and the construction trailers were about 3 blocks away from the actual job site. And they had 6 drones. And instead of walking a couple of blocks to go on site and walk around, they would fly the drone over, take video, and then watch it just on the big screen in there.
Right.
I wasn't sure if that was the laziest thing I've ever seen or the coolest thing I ever saw. But I think the whole drones and construction is that has to be a thing.
Yeah.
It makes so much sense.
It's really useful. Definitely.
So, yeah, you're in South Dakota, you got your master's. What did you do after that?
After the master's, I moved into an internship position with the ethanol company, designing kind of industrial buildings, just metal buildings and like steel buildings, for about 6 months while my wife graduated from her bachelor's. And then we moved to South Dakota, and I worked for a year and a half doing residential and commercial. And then recently, I think 3-4 months ago, before all the pandemic thing started, I moved to another company that does bridge demolition here in Boulder. So quite the journey to get here, between all the fields of structural engineering, but it's been a lot of fun.
Yeah. So what are the contrasts to doing houses and commercial to now doing bridges? I mean, how much did you see, transfers over? I understand that, the codes are kind of drastically different, but at the end of the day, stress is stress, I would think.
Yeah. So, I mean, between the industrial job and the residential job, just most recently, I didn't see a lot of difference. I mean, there's definitely a lot of difference, like in detailing and connections and just general like that. But again, like you said, like the forces are the same. The codes are really similar. I didn't really see a huge difference. With this new job, it's a little different. We introduced a new code, which is AASHTO. have to think about live load, traffic, and just different forces to the bridge. But again, at the same day, you're designing beams, you're designing piers, which I mean columns. You're designing kind of the same structure and components that are going to be designed in the same way or very similar way than the other jobs that I had. But at the same time, you're introducing these new loads and such. So there's a little bit difference, but when you're doing the calculation and such, I think everything is just really similar in terms of designing a beam, a steel beam, or such. I mean, there's a different checks for like plate girders and such that are just completely different than buildings. But again, it's the same procedure.
Yeah. So I'm curious about this. So with your masters and doing stuff with bridges, and now doing stuff with bridges, did you have a little bit of experience with AASHTO prior to this with your masters, or because the AASHTO to me was very overwhelming when I studied for the PE, and yeah, I mean, that thing is huge.
Yeah. And the name, like the way they name everything is just weird, because they go like 5.8, 0.2, 0.3, 0.5, like it just keeps going forever. But when I was doing my research, I kind of focused on a small part of the AASHTO goal, which were like the load distribution factors and the load rating factors. So I was a little bit exposed, but not too much. Right now, I've been a lot more exposed in terms of like the design of girders and just structures in general.
And did it feel like, I guess you had trained more in bridges in school than probably a lot of other people did, but going from buildings to bridges, did it feel like a leap at all? Like you had to restart, or like, before you started work, did you study a bunch to like make sure you're on top of it, or is a smooth enough transition?
I wouldn't say it was like completely smooth, just because again, it's a new company. There's a new like kind of set of rules within the company, design standards and such. It's always a challenge when you move companies. It's going to be different than your previous company. I was glad I had the experience with my master's just from inspection of bridges and kind of looking at the AASHTO code and such. That was not too bad. And again, what we do is kind of a little bit different than like new design of bridges. It's more like demolition. So there's a lot of, I wouldn't say like guesses, but there's a lot of things that we need to figure out on our own rather than just rely on the code.
Like dynamite.
Yeah, something like that. You just blow the bridge up. No, so we kind of have to think outside the box when we're doing design, and that just comes to like basically just the basics of structural engineering and statics and a little bit of dynamics. So it was kind of a smooth transition, but again, there's kind of a rough few weeks at the beginning where you're trying to understand how everything works.
And is there software that you use? Like what are the calculations when demolishing a bridge? Is it you're making sure you have stability as you go back down?
Right. So I had never designed a bridge from start to end, but I can imagine there's like construction stages when you're erecting, I don't know, the girders and depending on the method that you're building the bridge. And it's the same in the deconstruction process. Whenever you kind of cut a girder, a lot of times we lower like big sections, like a whole span, a whole truss down. So we have to check how the load paths change it when you change the like loading situations and such. So yeah, it's just kind of thinking about the problem than actually like solving the problem right away. So you have to think how the load paths change, where the stresses are now that you're changing kind of the original state of the bridge. You may be switching from negative moment to positive moment in certain sections that were not really designed for that. So just kind of think about those little things. It's probably 80% of the work than just actually do the calculations. I've been using Midas a lot just to do like finite element analysis, and I mean, it's the same when you're designing a bridge. You just kind of thinking backwards. How do you take it apart?
That's fine. I've never heard of Midas. What is that software?
I didn't hear about it until I started this new job, but I've been loving it. It's awesome.
Really?
I don't know if it's just for bridges, but there's a lot of functionalities that it gives you like a really detailed calculation, like sheet. It gives you a lot of nice results and such. It's been great since I've been using it.
If someone, is let's say, either already working in building engineering and wants to transition over to bridge engineering, what would you say the best path for that is? And like, how do you, what is the same? You know, you go in your interview and you're like, well, I've never done bridges, but here's what I know about buildings that will help me get there. Like, what can you say translates perfectly?
I'll say it gets harder and harder the more experience you have in one of those.
Yeah.
For me, about 3 years into my career, so it's not a huge kind of jump. But I think it's hard to say. There is a lot of similarities. You need to be familiar with the code. The way they design for shear is a little different. The way they design for bending in bridges is a little different. Now you're introducing dynamic loading. So if you're not familiar with that, that's gonna be a new experience. I'll say the most important thing is knowing kind of the basics of engineering, like statics and some dynamics, knowing them like really well. Because at the end of the day, a girder or a house beam, their beams, they may be a lot different in size, but some of the checks are really similar. So yeah, just kind of knowing the basics of engineering and these basics of design. The materials are the same. The materials are not going to behave different in a bridge that they're going to behave in a house or on different structure. It's just the way you design is a little bit different, kind of different checks and such. So yeah, the most important thing is just kind of knowing the basics of engineering when you transition between two different fields like that are too different on the eyes of everyone.
Mm-hmm.
So now having, you say, 3 years of experience, what do you think, or what do you wished you knew when you started engineering?
Oh, that's a hard question.
Yes, finally.
The thing that I has helped me the most, and it's not even related to like engineering, it's just being kind of proactive during the design, like being organized, having like a good record of all the design things that I've done. That's gonna come really handy when I apply for the PE. When I move in my career, kind of learn from those maybe mistakes that I did before and not try to make them before. So I think I didn't do these a lot when I graduated. I've been doing a lot more lately, but just keeping track of kind of design things and kind of keeping track of maybe new things I learned every day. I think that's been really helpful in the past. I think a year that I've been doing that. I mean, all schools are going to give you a really good education if you are proactive in learning what they're teaching you. I kept basically all my structural engineering related notes since my sophomore year, so I have everything kind of on my computer. Whenever I have to reference something, I can go back to the notes. And the good thing is like the professors used to like reference the code whenever they have a formula, so I know exactly where from the code that formula came from and that design came from. So that's been really helpful, and I probably encourage everyone to do something like that and just be organized with the notes and just really focus. And the other thing is not just take the notes, kind of do a summary on your own. And that's what I used to do when I was like studying for exams. I don't consider that really studying because I already kind of knew everything and you were able to kind of reference that material during the exam. But just kind of making a summary for yourself on how you're progressing through your career as a student, and then when you start your first job, it's the same thing. You're gonna keep learning, so you're gonna have to kind of keep a summary of all those things. So I think that's probably one of the things that I wish I had done since the beginning, but I'm glad I'm doing it early on in my career.
Yeah, I always would just burn all my notes at the end of the year, which felt really good at the time. So I'm glad I did it. I wish maybe I had some, but that's all right.
That was something, my first job, one of the guys there told me or showed me that he kept a notebook of every new type of calculation he did. He made a copy of it, put it in a notebook, and like tabbed it. So he would never have to like remember how he did something again. And it seemed, it was super helpful. And it was something that I started doing, and then I haven't in a few years, but
totally. Yeah. I think there's I'm curious, Luis, how you keep organized on that sort of thing. But since Zach just mentioned it, and I have it right next to me, so when I first started, I had a big binder of like all these resources, and then you kind of stop looking at them a little bit. Like especially as I'd go to a new job, you're like, oh, I need to, find this bootleg PDF of a masonry book online and print it out and like tab it up, and like you just stop looking at it. And that was really good early on. And now what I do is anytime there's like a new calculation kind of thing. This is about like macrofiber reinforcing. I have like this kind of fancier looking notebook, so I like writing in it. And yeah, I'll make a page on like some specific topic. And I found that's been like super fun because it's, I don't know, just a little more bizarre stuff that you don't really need like a reference for here. Strut and tie modeling, Connex Tech. I don't know, stuff that was interesting that I wanted to spend like an hour looking into at work. That would help me, but yeah, wasn't going to be like a full-on reference kind of thing. So that's how I kind of keep track of like new things currently. How do you like to be organized at work? Like you're saying, that's super important for staying on top of your stuff.
So I do a little bit something a little more fancy. I use this program called Notion. I don't know if you're familiar with it, but it's basically like a program that lets you do basically anything you could possibly imagine, like databases, pages, relational databases. So I have a lot of things kind of connected with each other. So I have what I call a database, which is basically like, think about like a Excel spreadsheet, but each line can be its own page, and within each page you can have more pages. So I have kind of a database where let's say I learned something new about below the hook standards. That's something I did at work recently. So I create a page within that, and then I write maybe a little bit of what I learned during that procedure, and I can tag it. Let's say, okay, this is below the hook, but I can also tag it with, let's say, it was a concrete beam or a steel beam or something like that. I can give it tags to reference it later. So you can imagine having all this information with tags that you can reference later. It's been something so powerful, and I don't use it just for work. I use it for like my podcast. I use it for organizing tasks, for all sorts of things.
Yeah, this is super cool. I'm looking at it online, and I really like the tag idea. And it looks like so it can be mobile or on your computer.
Right.
Can you print it out in an organized way? Like if we're looking towards the PE, right? Will you take that in like the next time it comes around, maybe? Like,
yeah, is next year.
Nice. Is there a way that you can print these out in like a reference that you can still use the hard copy in a similar way? Like it'll tell you what page hook is on? I
haven't tried to like print them out. I know you can do like PDF prints of like pages or even the database. And I'm sure it includes some of the properties that you can kind of look, and maybe you can organize it that way or such, but I'm not sure how I'm going to do that quite yet. I have like a placeholder for my PE study database whenever I get to that. So that's been kind of useful. And the good thing is, for example, if I create a new page, I can reference that like knowledge page that I call into that specific page, and I can sort it by, I don't know, material or filter it by, I just want to know about like concrete banding and all the things that I've learned in the past year about that. So that's been really powerful to have.
All right. So this is probably a question. We kind of keep jumping around. So that's kind of probably how Max and I's minds work. But something that I'm curious about, you went and got your master's doing some bridge stuff. Then you worked kind of more on residential, commercial building side. Now you're back to bridges. Where do you want to take your career? Like, what's the end goal? Let's say maybe there's not, but where do you see your career going?
That has changed a few times. I just always tell people that I just like structural engineering in general. Like that's what I really like, and just like kind of mastering the basics of structural engineering. It's really important. The other really important thing for me is to be at a company that I'm challenged, and I have like a path of kind of becoming more experienced and becoming more be like a project manager, and eventually maybe even a partner in the company. And that's a company that I think I'm on right now, which is Foothills Bridge. And
it might be a hard question, but like, how do you know when you walk in, You had had a little more introduction with these guys. You had already had like one interview and waited some time, but like if you're going in for an interview, how do you feel out that this is going to be a company where you're going to be able to grow, where you're going to be challenged, where you're going to have good mentorship? How do you feel that out in one day, in 1 hour, like an interview?
Yeah, so I had talked to them back in 2018 when I first was looking for jobs, just through like video calls like this. But I got to meet like the president of the company and a few of the partners and talk to them for about an hour. I think I had like even a second interview with them. And even back then, I mean, just them talking and kind of explaining how the company structure works and explaining what kind of work they do, you kind of get hints of, okay, maybe this company doesn't really let you move up too far into like leadership positions. Or maybe this company is just wanting you to come here and do your job and they don't really care about you. Mm-hmm. I got a better feeling about that in the second interview, I'll say, just because I was in person. I got to meet a lot more of the people at the company. They explained how you start as a designer and then you move into like a bridge engineer, and then you move into like a bridge engineer associate and such, and you keep moving forward. And at the end of and they even tell me that like the end goal is for you to become a partner of the company. Like we're going to retire at some point and someone else needs to take leadership of this company. So they really encourage that. So again, that was pretty obvious in that sense. Just kind of works they do, just talking to like the project leads, knowing that they do a lot of really out of the ordinary designs that require really different techniques that a building will do or a house will do. That really tells me that, I mean, there's challenges. They don't really focus on, let's say, all the design has to be hand calculation, or all the design has to be software, or all the design has to be spreadsheets. It just depends on what kind of design you're doing, what kind of checks you're doing, and that just tells me that there is not really a right or wrong answer when you're doing calculations, which means it's different and it's challenging, and you have to maybe combine two things to find the right answer for one problem. And so yeah, just kind of be listening for those little things that give you hints of what kind of work they do. Obviously, I researched them before I went into the interview and kind of knew exactly what they were doing, but kind of getting more into the weeds of, okay, this is how a demo sequence works, and these are the projects that we've been working on, really told me that, I mean, it was challenging and it was interesting.
Yeah, that's cool. I feel like that's such a hard thing to figure out right off the bat, but do you prefer smaller or larger companies as far as like ability to grow with the company and move up and personal relations in the company? Do you think there's if you've been in a little bit of both, one is better than the other?
I would say that a lot easier in a small company. You get to know kind of who is the leadership of the company faster and get to know them closer a lot faster. The first company that I worked for, I mean, you had some contact with like the kind of leaders of the company, but it wasn't much, honestly. So, I mean, there's definitely a lot of more growth opportunity if you want it in a small company than in a big company. I'll say it's probably a lot of people prefer the big company, and that's okay. I probably prefer a small company now since I've been doing it for a couple of years now, just because it's more kind of relaxed and you get to know everyone.
Yeah.
Is your current company at all interested in using drones for anything?
So I talked to one of the partners recently because they knew I'm doing drone inspection using bridges, and they're kind of looking into it. I don't think so much for like inspection of the bridges. I mean, maybe some pictures to like maybe look at some critical sections that they're considering during the demo process, but it's more so for like kind of marketing after they finish a job and give that to a client as a deliverable. So
right. Definitely. I've been trying to figure out how we can get a drone or a couple drones, and I haven't been able to convince anyone yet. Most contractors have them, and they've been doing the drone footage and stuff. But yeah. I think it'd just be cool to go fly drones around.
It's a lot of fun.
Yeah. Okay, so I guess the last question I have, maybe Max has got some more after this, but what do you think makes a successful engineer?
That's another hard question. But from what I've seen and just talking to other more experienced engineers and other younger engineers, I think it always comes back to like the soft skills. And I wouldn't say people that are extroverted are better at that, or people that are introverted are bad at that. I consider myself an introverted. I'm really introverted. If I go to a big crowd for an hour, I'm gonna be exhausted after that hour. I know people that will just want to be there, but I figured out that was really important for me to realize that communicating and being able to write better and communicate better with other people, it's really important. It was even harder for me knowing that English is not my first language. So I had to like really train myself to do all of these things. I presented at the Structures Congress one time, and I've been going there for like 3 or 4 times, being involved in committees and just being super involved and being able to like give back to communities through EWB, I think is really important. I just think you need to, for example, if I was just focused on structural engineering and not really care about other disciplines of engineering, I don't think I will have been as successful as I am right now. I'm just through EWB, just knowing how water distribution works a little bit, being able to help them and just giving back to my knowledge. I think that's really important. And again, the technical part is important too. You need to know how to design a beam. You need to know all of these things. But if you graduated from school, you probably know these things. You can reference them from your textbook, from your notes, from code, from anywhere. But at the end of the day, you need to be able to communicate with people. You need to be able to be more proactive in that sense. And I think giving back to like volunteering, it's a really big part of my career so far. And I know a lot of people should be doing more and will be really fulfilling for them to do so.
That's great.
Awesome. Well, thanks for joining us this week. Really appreciate your time, and it was good having you on the show.
Yeah, thanks for having me.